And we'll go over to, let me see, I need to go back. And first, share screen up. And we want to share the visualizer. There we go. Okay, this is lesson 2.3, and we're going to cover average rate of change. And you're going to be able to calculate the average rate of change using units. I mean, that's basically what we're dealing with, proper units. So we're going to talk about that in a little bit. And then this is going to be supported by one of the punchline worksheets, worksheet 7.2. So after I get done going over this presentation with you, I will link that up, and I will also put a copy of this outline. I'll have it available to you, but probably well, I'll take it back. I do not want to have you just write out the outline. So I'm going to go ahead and upload this presentation right after I get done with you. And you'll have that available to go back and look at. So again, you're going to take notes in your math notebook, and you'll also upload those notes to my Student View Dropbox by 11:59 p.m. on Sunday. Okay. All right. So let's take a look at what we've got. So average rate of change. What I had said is that, just creeping this up here, you're going to calculate the average rate of change using proper units. So let's first of all talk about what average rate of change is. Here are three examples of graphs of linear functions. And let me use my blue pen here if I can find it. And if not, I'm going to use my black pen. Let me see. My blue pen. There it is. So all of these are showing slope here. You're seeing examples of slope. Average rate of change is just slope. That's all it is. It's a fancy word for slope. So slope equals, or is the same as, m. And m originally came from the Latin, but we think of it usually with the French because Descartes created the XY coordinate chart. Descartes was a Frenchman, and he talked about slope in French terms, which was mont, or mountain, or montaño in Spanish. So that's why you see that letter M. And slope is basically the rise in your y coordinates, right, over the run. And run is your x coordinates. So you're going to run with the x's. So you're going to rise with the y's and run with the x's. So the y's, of course, are going up. And so we would be looking at going up for the y's. That's the rise, and then the run, you're going through the x's. All right. So that also equals, if you're thinking about it, y2 minus y1, and you've had, of course, this experience before because this is the slope formula, over x2 minus x1. So this is what slope really is. But in the case of rate of change, then we're using units. So rise in y's would be rise in y units. And run in x's would be in some kind of units, okay? That's what we're trying to do. So we're going to talk about what units are, but let's go ahead and just look at example here. So here I've got M equals, or slope equals rise over run. And so let's just see what it is. So we need to find a couple of points in our graph. So we're looking at this graph. We just need to find any points that actually are convenient to graph. So if I look over here, I notice that this line goes through where x is -2 and y is 0. So I've got a point right here that I can use. And I also notice that up here, I've got that x goes through 2 while y goes through 8. So I've got a point up here. And so what I'm going to do is I'm just simply going to measure the rise over the run. Okay, that's all you're doing there. And so in this case, we're going up from where x is, let's just put the coordinates in. If this is x is 0, I'm sorry, x is -2, y is 0, then when we're rising with the y's, we're going from 0 up to 8, so that's 8 units. And the run is we're going over, now we're going to the left 2 units. So this is 2 units up here. And so that's 8 over 2. And of course that would equal, we could simplify this to 4 over 1. So slope is 4 over 1 in this particular case. All right, and so now this is what we call positive slope. We're starting from left and we're going to right. We always start with the left-hand side here. And by the way, this point over here is x is 2, positive 2, and y is 8. Okay? All right. And so let's see, this is positive slope. Positive slope. Now negative slope, you'll notice the line goes from left to right down. That's what's going on here. Again, we're going to pick 2 easy points. So I see a point here that crosses the units. Now, this particular graph is a little different than this one. In this graph, every 2 units were shown. Here it's every 5. So these are all, we count these 1, 2, 3, 4, 5. Each one of these grid hatch marks is 1 unit. So knowing that, I can go ahead and figure out what the coordinates are. So this is x is -3, and y is going up 1. Okay, -3, 1. All right. And then let's find another point here. So there's a point down here. And that's x is -1. And your y is also negative. It's -1, -2, -3. Okay, so you're just counting. So remember, when you're on the left-hand side of the y-axis, your x's are always negative, and both of these points are on the left-hand side. And then when you get down to below the x-axis, then your y coordinates are also going to be negative. So you'll notice that these two are both negative, whereas this one, x is negative, y is positive. Okay, so going from left to right again, we're going to go down 1, 2, 3, 4 units. Okay, so down 4 units. And so I'm going to put this down over here because we're just kind of short on space. This is, again, negative slope. So we're going to go down 4 units. So the rise over a run. Down 4 units is -4. And then we're going to go to the right 2 units. So that's over 2. So simplifying that, that's going to equal negative 2 over 1. Okay. All right, so the other way we could have done it, we could have done the change in y over the change in x. So I could have done this is m equals, oh, I wrote this wrong. This is rise over run. I sometimes get ahead of myself in my thinking. So again, the first equation, slope is rise over run. The rise is negative, so it's negative 4. It's actually going to go down. And the run is over 2. And that's positive because we're going from left to right. Negative 2 over 1 is the slope. Now, the other way of doing it, again, is to use the change in y, which is y2, minus the change in, y2 minus y1. And then change in x is x2 minus x1. And so in this case, y2, well, this is my second y, so we're going to call this first point up here, negative 3 is going to be x1, y1. And my second point on going over here to the right is x2, y2. Okay. So y2, let's find y2, it's negative 3. All right, minus y1, y1 here is 1. Over x2, x2 is negative 1, minus x1, which is negative 3. Now here you have to be careful. You have to put in negative 3 here. So you've got double negatives. And that simplifies to m equals, let's see here, negative 3 minus 1 is negative 4. This is negative 1 plus 3. So negative 1 plus 3. So negative 1 plus 3 is negative 2. And then again, that simplifies into m equals negative 4 divided by negative 2 is positive, or I'm sorry, this is positive 2. So negative 4 divided by positive 2 is, again, negative 2 over 1. So these are the same, okay? All right, so that's negative slope. Now the last one here is, this is zero slope. Now here they actually showed the points, they showed 2 points. You can't read them very well, so I'm just going to highlight them and write them in as to what they are. So again, this is the x-axis, this is the y-axis, and we're just going to looking at these units each are 1 unit. Okay, so this is x is going from left to right. This is x is negative 3. So negative 3, and y is 1, 2, 3, positive 3. Okay, so that's going to be my x1, y1, and my x2, y2 is going to be x is 2, y is 1, 2, 3. Okay, so I'm going to use the y2 minus y1 on this one. I think it's best because of all the negatives involved, and we want to make sure we understand what's going on. So, but we could do it either way. Well, let's do it both ways. So this is, oh, and by the way, you'll notice again, this line is horizontal. We'll just mention that. All right, so, okay, so m equals rise over run. And so notice we aren't going up or down. We aren't going up or down. We're staying there. So that means that the rise is 0. And the run, we're going from where x is negative 1 to where x is 3. I'm sorry, not -1, x is -3, and over here, x is 2, -3, 2. So let's just count those. So 1, 2, 3, 4, 5. So that means we're running 5. And so, but 0 over 5, as we all know, is 0. So this is a slope of 0. And this is 0 or no slope. Okay. 0 or no slope. Now, doing it using rise over run, we'll just do it that way, where the rise over run is y2 minus y1 over x2 minus x1. So rise over run equals y2 minus y1 over x2 minus x1. So my y2 here is 3. Minus my y1 is 3. Remember, we have the negative sign, so that's added to it. And then x2 is 2, minus your x1 is -3. So we got a double negative going. So that means our slope is going to equal 3 minus 3 is 0. And 2 minus -3 is 2 plus 3. So m equals 0 over 5, which equals 0, which is the exact same result as we got up here in the top. Okay, so bring that up so you can take a look at it. All right, so you've got now the 3 types of slope, but like I said, we're going to do this in units. So rate of change is talking about units. That's what this means, units. You're dealing with units. So I'm going to take my original graph here. I've kind of enlarged it. And I'm going to add to it so that you can see what I mean by an example that involves units. So I'm just going to, let's see here. I want to get a good one here. We've got plenty of room. On my line. Oops, I did it wrong. Sorry about that, guys. So we'll just have to ignore the wavy line there. All right, so we're going to call this line A, and we're going to call this line B. And we're going to call the x values water flow, and we're going to call the y coordinates minutes. All right, so y is minutes, x is water flow. This is going to be line A, this is going to be line B. So we have 2 different things going on here. All right. It's not unusual when you're dealing with these kinds of things to have comparisons of 2 different things. I'm going to put this on. How do I want to do this? All right. Well, I see what's going on here. I misread my chart here. Okay. This is about water flow. Okay. And so they're going to show you time in minutes as your x. Time in minutes. This is your x. And then over here, this is going to be gallons. This is going to be gallons. Gallons of water. So this is y. Okay, so you've got, we're only really going to deal with this quadrant here in this particular instance. So we're just going to get rid of that down there. Okay, and let's make sure I've got. Okay, so we're gonna use this now. So for the A situation and the B situation, I'm just gonna kind of divide this. So A, this is A. So for A, we're going to talk about the average rate of change, average rate of change. So we're going to call this ARC, just average rate of change, abbreviating. So ARC is going to equal, so we're got to figure out the rate of change. So we're going to have to get some points. So I've got a point here that I can see with A, and I've got a point here. All right, and so this point here is at x is 0, y is at 4. And then I got a point up here. I'm going to ignore the f here, so I'm going to get rid of it. And here x is 2, y is 8. All right, so we're going to go ahead and figure out what the rise is. So we're going from where the rise, and remember, is y. So remember, these are x and y. It's x1, y1, x2, y2. So that's 4. And then I'm going up to 8. So the difference between 4 and 8 is 4 units. So I've got 4 over, and then the run is, we're going to go from where x is 0 to where x is 2. So that's 4 over 2. So the average, and remember these are gallons. 4 gallons. So we're going up for the rise, and then the run is going to the right. So that's going to be minutes. So that can be restated as, you can simplify this as 2 over 1, so 2 gallons over 1 minute, or we can call it 2 gallons per minute. Okay, 2 gallons per minute. All right, so now the other one's a little trickier because it has a negative number here. Normally we don't use negative numbers in figuring these things out, but I'm just going to, for the sake of the example, I'm going to use it. And I'm going to use this point over here. So here, this is going to be my x1, y1. X is negative 2, y is 0. So that's x1, y1. And then over here, we've got x is 4 and y is 4. So that's x2, y2. And all right, so that'll be my B example. So my average rate of change, what is it going to be? So I'm looking at this and I'm going to go from where y is 0, that's y1, over to y is 4. So we're going up 4 units. So that's 4 gallons. Okay. And my run is considerably longer, it looks like. My run is from where x is -2 to where x is 4. So if you take the absolute value of that, that's 2, 4, 6 units. So that would be 6 minutes. Okay, so you have to keep those positive when you're doing this kind of thing, right? So 4 gallons per 6 minutes. That means my average rate of change equals, reducing this, 2/3. So 2 gallons for 3 minutes, or 2 gallons per minute, per 3 minutes, pardon me. Let me move that over just a little bit. 2 gallons per 3 minutes. So that's a considerably slower, of course, fill rate, okay? All right, so that's basically what rate of change is all about. Now you can use y2 over y1 equals x2 over x1. So I'll just do that for a just so we can see it. So average rate of change equals, okay, so using the first one, this was my x1, y1, 0 and 4. And this is my x2, y2, 2 and 8. So y2 minus y1 over x2 minus x1. My y2 is 8. My y1 is 4. So y8 minus 4, because both of those are positive. You still have the negative sign, but the two entries were positive. And then x2, which was 2, minus x1, which was 0. Okay. All right, so that simplifies to average rate of change equals 8 minus 4 is 4 over 2, which simplifies to 2 over 1. Well, remember, these are gallons, so gallons per minute. So this is 4 gallons over 2 minutes. Well, we can simplify that more, can't we? So that's 2 gallons over 1 minute. All right. So simplified form, 2 gallons per minute, which we could also show as 2 gallons per minute this way. All right. So you can see the whole thing. Your answers are exactly the same as before. And you could do the same thing, of course, with the B work as well. So again, average rate of change, the only thing you're really looking at is, this is just plain old slope. You're doing slope stuff. It's just that you've got to add the units. You've got to add the units. And that's why they call it rate of change. So it's just, anytime you see units, then you call your slope rate of change. Okay? All right, so I'm going to go ahead and upload this, and I need to stop the recording. So let's stop the share first. And I'm going to stop the recording.